Hi everyone, I'm Joanna and this is Bharat, and we are going to speak about what MIRAI attack is. So first Bharat will give you an introduction about the attack, that is MIRAI, and then the top countries of the origin of MIRAI, and finally what is MIRAI botnet. And I will be speaking about how MIRAI works, the MIRAI code, MIRAI attack vectors, and lastly how to defend against MIRAI DDoS attack.
Hi, by now, many of you have heard that on September 2016, the website of renowned security journalist Brian Krebs was hit with one of the largest denial of service attack to date. The magnitude of that attack, the status of its target within the InfoSec community, and the heaps of drama that followed made this one of the most high-profile DDoS attack to date. Investigation of the attack uncovered 49,657 unique IPs which hosted MIRAI infected devices. As previously reported, these were mostly CCTV cameras, a popular choice of DDoS botnet herds. Other victimized devices included DVR and routers. Overall, IP addresses of MIRAI infected devices were spotted in 164 countries. As evidenced by the map below, the botnet IPs are highly dispersed, appearing even in such remote locations as Montenegro, Tajikistan, and Somalia. Interestingly, since the source code was made public, we've also seen a few new MIRAI-powered assaults. This time they took the form of low-volume application layer HTTP floods, one of which was even directed against Incapsula.com. Characterized by relative low request per second counts and small numbers of source IPs, these look like the experimental first steps of new MIRAI users who were testing the water after the malware become widely available. Likely, these are signs of things to come, and we expect to deal with MIRAI-powered attacks in near future. What is MIRAI botnet? MIRAI is a self-propagating botnet virus. The source code of MIRAI was made publicly available by the author after the successful and well-publicized attack on Krebs' website. Since then, the source code has been built and used by many others to launch attacks on internet infrastructures. The MIRAI botnet code infects poorly protected internet devices by using telnet to find those that are still using their factory default username and password. The effectiveness of MIRAI is due to its ability to infect tens of thousands of these insecure devices and coordinate them to mount a DDoS attack against the chosen victim.
Now let's see how MIRAI works. There are two main components to MIRAI. One is the virus and the other one is command and control center. This virus contains the attack vectors. MIRAI has about 10 vectors that it can launch and a scanner process that actively seeks other devices to compromise. The command and control center is a separate image that controls the compromised devices, sending them instructions to launch one of the attacks against one or more victims. The scanner process runs continuously on each bot using the telnet protocol to try and log into IP addresses at random. The login tries up to 60 different factory default username and passwords. When login succeeds, the identity of the new bot and its credentials are sent back to the command and control center. The command and control center supports a simple command line interface that allows the attacker to specify an attack vector, a victim's IP address, and an attack duration. The command and control center also waits for the existing bots to return newly discovered device addresses and credentials, which it uses to copy over the virus code and in turn create new bots. Shortly, according to this picture, if you see, the first step is the existing bots discover new open devices. Next, the details are sent to the command and control center through internet. The third step is the command and control center copies viruses into the new devices. And the last step is the command and control center commands the bots to attack the victim. Now I'm going to speak about the MIRAI core. The virus is built for multiple different CPU architectures, for example, ARM, SPARC, PowerPC, Motorola. The virus deletes itself from bot's disk after loaded into the memory. Rebooting makes the device free of virus. The attack vectors are highly configurable from the command and control center, but by default, MIRAI tends to randomize the various fields such as port numbers, sequence numbers, identification, etc. in the attack packet, so they change with every packet sent. Well, I guess I told you about MIRAI vectors. Yes, MIRAI has 10 vectors. Okay, so the 10 vectors are actually generic UDP, VSE, DNS, plain UDP, TCP synchronization, TCP acknowledgement, TCP stomp, GRE IP, GRE Ethernet, and HTTP. So I'm going to speak about 3 vectors here. So first one I'm going to speak about is DNS. So DNS attack included in MIRAI is an interesting attack and probably the most notable due to the high profile attacks it was used in. MIRAI is not the first time this attack was seen in wild, but it is likely the first time it was included was in an IoT botnet, which added critical damage potential. The next vector I'm going to speak about is the VSE. Okay, now what is VSE? VSE is the Valve Source Engine attack. So there is a fascinating relationship between online gaming and DDoS. Online gaming has long been at the center of attacks, and it can be argued that the proliferation of DDoS tools and techniques can be somewhat attributed to this space. Simply put, people have been regularly and creatively attacking game servers for years. So basically the VSE attack is specially crafted for servers that run certain games from the developer Valve Corporation. These online multiplayer games are built on a software framework that is called a source, which is responsible for things like rendering images, sounds, gameplay, networking, etc. The next vector I'm going to speak about is Stomp, TCP Stomp. So this TCP Stomp attack is one of the more interesting attacks in MIRAI. In fact, it was reportedly designed to defeat certain DDoS mitigation techniques because it is an insertion attack. The intent of this attack is to establish a three-way TCP handshake, after which the attacking nodes send an acknowledgement flood within their session that has already been whitelisted by protection sets. The final topic I'm going to speak about is how to defend against MIRAI botnets DDoS attacks. MIRAI will continue to be a threat until the poorly protected devices are secured. We have to stop using default or generic passwords. We have to disable all remote access to your devices. So I hope you all understood the content of this attack. Thank you.